Oh yeah.
Ooh, that's too bad.
All right, guys. I've just started the presentation feature on in Google Meets. I'm good morning again. So I'm gonna show you the stuff for this week. So today is May 11th, 2020. There is a new pacing schedule for this week. Okay, if you click on this, let's do that. Posted new material over a week of May. And here I've outlined the targets for this week. We are going to be talking about things like related to circles once again, but more specifically, we're going to be talking about arc length and radian measure. And if you click on this Google Doc, okay, this is what's going to pop up. This is the pacing for the Khan Academy material that you're going to watch. So you're going to watch this video on your own. You're going to take notes on it. There are these two videos. Okay, these two videos you're going to take notes on, and you're going to submit that as one of 3 note-taking assignments. We're going to do this arc length exercise during office hours today. Okay, so you get that out of the way. I've also posted these suggested due dates. Okay, and so after this session, you'll be done with arc length. And then going further down, these are other videos that I want you to take notes on, and further other exercises that we're going to do. But we're going to take this one day at a time. But it's just the same format as in the previous week. Okay. All right. Let's take a look at the Khan Academy and how far you'll need to go. If you recall last time, we had to click connect 14 times, right? So we're just going to do that again. So once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I am over here. If you don't have your Khan Academy window opened up yet, please do so. And we are going to be working on this item over here, which says arc length. Okay, so I'm going to give everyone here a second to just catch up, okay, and let me know when you are ready.
So
Ready.
Okay.
Mr. Chan, when you're flipping through those windows, do you ever get a thing where it says like no assignments found and then you have to click previous?
Yeah, I get that a lot. I don't know why that happens. It's Khan Academy is kind of glitchy. I mean, they are nonprofit, and they're going off of donations. So, but they are a huge asset to the learning community at this point. So if you guys find within your hearts, you guys should donate.
What?
So which exercise do we go to?
So I'm waiting on you guys. Are you on the 14th page, Michael?
I'm going there now.
Okay, and you're looking for the assignment that says arc length.
Okay, I'll go there right now. Arc length. So it's an exercise, right?
It is an exercise, yes.
Okay, got it.
Got it?
I'm here already.
Did someone just finish the assignment?
No.
Yeah, that's fast.
No, I didn't finish. I tried to, and then I got the first one wrong because I thought
What's the first one?
I thought I might know what I was doing, but then I didn't. I just got all of them wrong, so I could do it again because I don't want to.
Right.
You
Okay, so
should be able to
this
restart it
is
at
the
any
problem right now. Everyone have the same one?
Yes.
Yep. All right. So what I'm going to do is I am going to switch over to my tablet where I can write and articulate some of the ideas behind what arc length is. So I'm going to present the screen over here.
I think 120.
So this topic, okay, is very, very intuitive, okay? And what I mean by this is there is a formula to this topic, but I want you to try to understand this based off of logic, okay? So what I'm going to do before I get to the actual problem itself, I just want you to take a little note. So if you have paper and pencil, okay, please use them. If you don't have paper and pencil in front of you, please grab paper and pencil, okay? Everyone have paper and pencil handy? Yeah?
Yeah.
All right. So what we're going to do, let's just make a sketch of a circle, okay? So your circle doesn't now have to be perfect, but make your circle nice and big, like I have here, okay? And let's just go over some of the vocabulary, okay, that we had discussed last week, and that is every circle has a center, and all the points on the circle are going to be equal in distance to the center, and that distance is referred to as the radius. Remember that?
Yeah.
So this is the radius, okay, and all radii are going to be the same length within the same circle. Great. This angle over here formed by two radii, okay, we refer to as the central angle. So theta in this case is the central angle. So this is all vocabulary from last week. And what do we know about the central angle and the prescribed arc here?
I'm gonna call.
What do we know about the relationship between the central angle and prescribed arc?
Sorry.
Hey, Ricardo. Again, this is from last week. You guys have to be fluent in this before I talk about any future ideas here, right? So what do we know about the central angle and the arc measure, AB?
That they are congruent.
That they are the same, okay? They are the same. These two things are equal in value, okay? So the arc measure in degrees will equal to the central angle. So why is this important? Well, in this week's assignments, we're going to be talking about something called arc length, which is different from what the arc measure is, okay? So what exactly is arc length?
Would it be how long the arc is?
Yeah, that's exactly what it is. Didn't I say in the beginning of this of office hours today that what we're doing here is going to be very logical, right? So arc length is simply the length of the arc, okay? So arc length is equal to the length of the arc. Okay, so if I were to take that arc AB and like stretch it out and flatten it out, iron it out, okay, so that it's a straight line, okay, and I take a ruler and measure that, that would be the arc length of arc AB. So the question is though, okay, how do I go about finding what that length is though, right? The way to go about this, okay, is there's a really logical way to think about this. Okay, we can set up a proportion. Okay, can I give you guys like maybe 30 seconds to think about this? Okay, how can I use proportions to figure out the length of arc AB?
You can. Well, obviously we don't have the circumference or anything here, but we could do like the angle of the central angle over 360 equals x over the circumference.
Yeah, thank you for that, Emmett. So if I set up a proportion, right, the proportion between theta and the overall circle, right, that those two ratios should be proportional to the length of arc AB to what's the full length of the entire circle in terms of R? What's the full length of the entire circle in terms of R? I don't know what the radius is, but what is the full length of the entire circle in terms of R? How do I find the full length of the entire circle?
2r pi.
Yeah, 2 pi R. So from this, okay, I can then easily then determine what the arc length is. Remember, our goal in the last like minute or two, okay, is to figure out what the length of arc AB is, okay? So what I'm going to do is I'm going to cross multiply, okay? I'm not going to multiply both sides by 360 because I want to keep AB by itself. So if I multiply both sides by 2 pi R, I'll end up with this expression here. I'll end up with AB is equal to 2 pi R times theta all over 360. And if I were to rearrange some of this, okay, do you guys notice that, are there any common factors that I can maybe possibly eliminate? Are there any common factors?
Well,
360
isn't
and
AB equal
360.
to theta? So you can sub in theta for AB.
No, not quite. Just because right now, if you notice, the length of AB, we're talking about arc length here. It's not going to be the same. So right here, okay, these two things, Emmett and others, okay, these two things, these are in degrees, okay. AB, arc length here, okay, arc length, this guy, what do you think the measure is going to be? Like, what units are we going to be? What units should we have? Is it going to be in degrees, or is it going to be in terms of like feet, inches, meters?
Well, it should be in units because it's a measurement, not a like an angle or.
That's right. So I need you all to be perfectly clear on this, right? So the arc length, okay, is not going to be in degrees. Arc length is going to be some unit of like length. Okay, so some unit of length. So it could be things like inches, it could be centimeters, it could be feet, right? It could be kilometers, okay? So these are all units of arc length, okay? This is a measure of length. So anyway, back to my other question before, which was in this formula that we are like creating, okay? Is there a common factor that we can possibly eliminate?
360.
And 360 has a common factor with another number in that equation.
Two. 360. Make it over 180.
That's right. So if I were to simplify this, I'll end up with AB is equal to pi r theta all over 180, right? And there's something else, okay? And it seems kind of strange, this next simplification, but it is widely accepted and for everyone's convenience to rewrite this formula in this manner here. And it seems strange, but let me explain. It is accepted to rewrite this formula to look like this: theta pi 180 times r. Okay? It is more acceptable to write it like in this manner here. Okay? Well, actually, there's one more thing I forgot. So where theta, oops.
What makes that like more?
Let me explain. So where theta is in degrees and is the central angle. Okay, so these are the arc length right now. Okay, so this guy here is the arc length. Let me write that out. This is arc length of AB. I'll give you guys a moment to write that down.
Can you enlarge on it, please?
Which part?
The one that's in the box.
No
Thank
problem.
you. So wait, why is the theta pi over 180 in a parenthesis?
Yeah, that was what Emmett was asking about in a moment before. So the reason for this rearrangement is because later on in the week, okay, it will be understood that this thing right here, that this thing, whoops, that this thing has a name, okay? And that thing there, okay, is referred to as a radian measure. So I'm not going to get into that too much. I'm not going to get into it at all during this this office hours session, just because that concept is confusing to a lot of people, and I don't want to delve into it at the moment. Okay, but that thing that I just highlighted, okay, is the formula for something else, and it's going to repeat itself over and over and over again. Okay, which is why we want to rewrite it in this form here. Okay.
Wait, what else is
All right.
the formula for?
That thing that I highlighted in pink is called the formula for the conversion between radians and degrees. And right now, you don't know what I'm talking about. You don't know what a radian measure is, but
I
that
do know what you're talking about.
Oh, you do know what I'm talking about. Okay.
Because I screwed up one time and I needed to multiply by a certain number to get to degrees because I didn't know how to change my calculator.
Right. Actually, it has everything to do with that. You know how in your calculator setting when we were working with trigonometry, right? There was a radian setting and then there was a degree setting. You guys remember that? So anyway, that thing there, okay, that's highlighted in pink, okay, that is the formula to convert something from degrees into radians, okay? But I'm gonna talk about that a little more in the next office hour session, okay? But for now, okay, we should recognize, okay, that box right there, okay, is the formula to describe arc length. Cool? All right, so I'll take that as a yes. What we're going to do now, okay, is we're going to take a look at the problem in Khan Academy, which we started off the session with. It was a circle with a central angle of 120, and the circumference, it says a circle with circumference 18 has an arc with a 120 degree central angle, and we need to find out what is the length of the arc. Okay, so let me just recreate that over here. So question 1 in the Khan Academy assignments, exercises, okay, it looks like this. And you're told that this from here to here that this is 120 degrees, and the circumference is equal to 18. And we want to find out what is this guy right here. Okay.
So we should set up that proportion.
So wait a minute. If that is the circumference, okay, and you know, we can still pretty much like continue solving the problem using this logic about setting proportions, can't we? Right?
Yeah.
We can do the same thing, okay? So if the circumference is equal to 18, and I know that that is 120, right? What can I do exactly? There are a couple things you can do, okay? You can set up a proportion, or you can go about finding out what the radius is and use this formula directly, okay? Whichever one you feel comfortable with is entirely up to you, okay? So if you think about this, if this is 120 degrees, right? How many degrees are there in a full circle there, Kian?
360.
360.
It's 360.
That's right. And I want to know what is this arc length right here. I want to call that x, okay? If I call that x, it should be proportional to x divided by, what's the full circumference again, Michael?
What's the full circumference? The radius is 120, so it's 240.
No. The circumference. What's the
18.
circumference?
18.
18.
It's 18.
Oh, okay.
Right? The circumference is 18. So I got to find out what that x is. All I got to do now
Cross multiply.
is I got to
And can we
cross
Should we
multiply.
simplify 120 over 360 to just 1/3 to make it easier for ourselves?
Absolutely. So x is equal to 18 times 120 over 360. And like you said, we can simplify before we multiply things across. This is really 18 times 1/3. And 18 divided by 3, last I checked, that is what?
Six.
That's 6.
That's just 6. That's it. That's all it is. Okay? So that's 6. All right, so I want to go into over here, Khan Academy, and I want to type 6. And all right. All right, let's take a look at the next one. The next one.
Wait.
Yeah, I'm waiting.
Oh no, wait. I need to copy.
Okay, no problem.
This one we don't have the thingy.
Say that again.
Wait, so shouldn't we use that? Shouldn't we use like that full simplified formula here since we have the radius instead?
Yeah, that would be a great idea. It says here, what is the length of the arc? Either enter an exact answer in terms of pi, or use 3.14 for pi, and enter your answer as a decimal. Okay. And
All right, I copied it.
okay. And in this case here, you're asked to find out what is the arc over 20 degrees. Okay, so I'm going to draw this out. Okay, and in this case here, they gave us something like this, and it said that this was 20 degrees inside, and that the radius was how much again, Emmett?
The radius is 3.
The radius is 3. Okay, so the radius is 3, and we needed to figure out what this guy was, right? What that arc length is. So according to the formula I gave you during office hours today, that we had created together, it was arc length is equal to theta pi over 180 times r, right? Hey,
Yeah.
Kelvin, can you tell us what is theta in this case for this problem?
Um, 20.
That's right, it is 20. So we're going to substitute in the arc, what theta is, and we're going to find out what arc length is. So this is 20 pi over 180. Hey, Ricardo, what's r in this case? Ricardo, are you there?
No, he's not there anymore.
Not there anymore. Dylan, what's r in this case?
He left. Dylan is mute.
Dylan is mute. Michael, can you tell us what r is?
Yeah.
What is R? R would be 20.
No. Dylan, do you know what r is?
Three.
R, it's 3. That's it. It's 3. So all you got to do is just simplify this, okay? So 20 over 180, we can simplify that. That turns into pi over how much? 20 goes into 180 how many times? 9 times, right? And then 3 goes into 9 how many times?
3.
3.
3. So the final answer is pi over
3.
pi over
3.
3. That's all it is. So the arc length is pi over 3. Okay? And then the problem says you can enter this as a decimal or you can enter this in terms of pi. So I will enter this either way. Let me see here.
Done.
Pi over 3.
Yeah, in this case, it's easier. Just use pi.
Yep. Okay, the next one, it says, what is the central angle of the arc in degrees? A circle has a circumference of 6, and it has an arc length of 1. So I want to draw this. Everyone have what I have on the tablet here?
Yeah.
Yeah? Okay, I'm going to move this over. So the next one here says to do this. Okay, and we have this arc over here, like so. And the radius. Emmett, what was the radius of this problem again?
This problem doesn't give you a radius.
Oh, it doesn't.
The circumference is 6, so
No,
the
it-
radius would be 3.
Arc length. Oh,
No.
they gave us the arc length.
Yeah. No, Michael, the radius isn't 3 because of the circumference being 6.
Oh yeah, right.
There's
That's
one.
diameter, right?
And then the circumference is 6. And this time, we're sort of asked to go backwards here, right? To figure out what theta is. Cool? So looking at this, right? If the circumference is 6, and I know that the arc length is 1, okay? Would it be easier for us to use... Well, someone just finished. Would it be easier for us to use this formula here that I boxed in, or would it be easier for us to set up proportions?
Proportions.
Set up proportions.
Yeah, I totally agree. So
The only reason I finished is because I did this problem, and then the other one was the exact opposite of this.
no problem. So this is theta over Kian. Theta over how much?
Theta over 1.
No, theta over what's the full degree measure of a circle?
360.
360.
Oh, 360.
Yeah. So theta over 360 is equal to arc length, right? Because the central angle should be directly proportional to the arc length, right? So it's 1 over what's the full circumference there, Mike?
6.
6. So then to figure out what theta is, all I got to do is just isolate theta. I'm going to multiply both sides by 360. And if I do that, I'll end up with...
Then you have
theta
6
equal
theta
to-
is equal to 360, which is 6.
which is equal to 60. That's right. That's all it is.
So that's the answer, 60?
And then we're on the last one.
Yep, got it.
Okay, this one here, it says that we have a circumference of 6, and now we're asked to find the arc length with a 60-degree central angle. This is really silly. Why would they ask this question back to back?
Exactly. That's why I finished it so fast. Because they gave us the opposite
So the
one.
answer's
So I
one.
was like that.
So let's say you didn't
So the
catch.
answer is 1.
Let's say you did not catch what Emmett and I are talking about, right? That you didn't understand what exactly what we meant by that, right? So here you're told that this is 60 degrees, and this time you're asked to find out what that thing is, right? What is the arc length? Well, and you know that the circumference is 6.
Oh, we
So
did
what's the
this a
arc
while
length here?
ago. This is
Say that again.
We did this a while ago. This is like the problem before.
Exactly. It's the same exact thing. But again, if you didn't know this, right? So it's again 60 over 360 is equal to x over 6. Right? That's how you would set it up. Multiply both sides by 6.
So that's the
Here, what's 6 times 60?
360.
Yeah, that's all it is. It's 360 over 360. And last I checked, Mike, what is that?
1.
It's just 1. That's it. So this guy here is 1. So we're going to put that up there.
Done.
Okay. All right. I am going to again. So again, in summary, okay. Today, what we talked about, really important. The main takeaway
What?
here.
I'm gonna go in my room for my next session.
Say that again.
I 1 at 10. Oh, my bad. Sorry, wasn't.
Okay.
My bad.
So Michael, can you tell us what are the units associated with arc length again?
Feet, meters, pretty much your normal units. That you
Units
use.
of length.
Units
That's
of
right.
length. Yeah.
Thank you for that. Kian, what are the units for central angles and arc measures?
It's inches, centimeters, feet, and kilometers.
So for central angle and arc measures, it's all in degrees. They are all in degrees. Anytime that we're measuring like an angle measure, right, either for the central angle or the arc measure itself, that is in degrees. So I'm not saying that is like the only way of measuring central angle and arc measure, okay? But for now, we understand that central angle and arc measures, okay, they are measured in degrees, okay? And we understand that arc length, that is measured in units of length, which is like feet, inches, centimeters, and meters. And last thing that we had talked about, okay, that was new for today was that formula, okay? You can find out arc length either by setting up a proportion or by using that formula, okay, that I gave you there. Anyway, I'm gonna hit stop recording. You guys did great today. You guys are like true diehard office hours.